A massive visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, has astronomers worldwide both fascinated and honestly a bit terrified. Officially confirmed as the third known interstellar object, it carries an eerie potential. Is this colossal traveler a natural body, or might it be, an alien ship? Recent NASA data has sent ripples of fear and fascination through the scientific community, questioning everything we know about visitors from the stars. The breaking discovery. The discovery of 3I Atlas marked a historic moment in astronomy, revealing a visitor unlike any seen before. Detected moving at an extraordinary velocity exceeding typical interstellar speeds, it challenged existing models of natural celestial object behavior patterns. NASA's advanced telescopes captured data suggesting anomalous properties, including unnatural acceleration patterns and an unusual trajectory that frankly defies conventional gravitational explanations. Researchers like Dr. Amir Siraj from Harvard University have highlighted these deviations as potential indicators of advanced propulsion systems, setting off widespread debate about the object's true nature among the global scientific community. The stunning size of 3I Atlas far exceeds earlier interstellar discoveries, measuring approximately 10 to 15 kilometers in diameter, and igniting serious discussions about whether we are observing a spacecraft rather than a natural cosmic wanderer. From initial detection through detailed spectroscopic analysis, the international scientific community continues grappling with extraordinary possibilities ranging from exotic comet composition to genuine extraterrestrial technology. The implications of either conclusion would fundamentally alter humanity's understanding of our place in the cosmos and the nature of interstellar space. The discovery story. The remarkable story of 3I Atlas begins with its initial detection by the Asteroid Terrestrial Impact Last Alert System in early 2025, when automated survey algorithms flagged an object moving with unprecedented velocity characteristics. Astronomers quickly realized its trajectory was hyperbolic rather than elliptical, definitively confirming its interstellar origin from beyond our solar system boundaries. Its enormous size, estimated to be several kilometers across, dramatically dwarfed the infamous Oumuamua and 2I Borisov, making it by far the largest confirmed interstellar visitor discovered to date. Dr. Robert Warwick, who previously discovered Oumuamua at the University of Hawaii, coordinated initial observational campaigns revealing mysterious activity patterns indicative of possible artificial influence or control mechanisms. The object's calculated path through our solar system appeared to be deliberately planned, with intriguing timing and orbital alignments that prompted intensive scrutiny from major observatories worldwide. Global astronomical networks mobilized for an unprecedented international data-gathering campaign, dedicating thousands of observation hours to studying every measurable aspect of the object's behavior, composition, and structural characteristics before it passes beyond detection range. A stranger in our midst. As 3I Atlas traverses our solar system, its extraordinary properties consistently challenge natural explanations proposed by conventional astrophysics models. The object exhibits complex outgassing patterns inconsistent with typical cometary activity, suggesting an internal energy source actively controlling its emission characteristics rather than passive solar heating. Advanced spectroscopic data reveals a surface composition featuring unusual metallic elements and compounds not typically found in natural asteroids or comets, sparking intense debate about whether it represents an artificial construct. Astrophysicist Dr. Marco Micheli from the European Space Agency has pointed out the object's highly reflective surface properties and precisely controlled thermal emissions as potential evidence of technological design and manufacturing. Most puzzling is the object's demonstrated ability to withstand intense cosmic radiation and extreme temperature variations without apparent structural disintegration or expected material degradation. These collectively puzzling characteristics make 3I Atlas a prime candidate in humanity's ongoing search for evidence of extraterrestrial spacecraft, fundamentally transforming how scientists approach the study of interstellar objects and their potential origins. The mounting anomalies continue defying conventional astronomical explanations while supporting increasingly exotic hypotheses. The predecessors. 3I Atlas follows in the cosmic wake of two notable predecessors that have, really expanded our understanding of interstellar visitors. Oumuamua, the first confirmed interstellar object sighted in October 2017, and Comet Borisov, observed in August 2019. Each of these brought unique mysteries that, honestly, challenged established astrophysical models. Oumuamua's extremely elongated, cigar-like form, and its completely unexplained acceleration away from the sun puzzled experts around the world, while Borisov displayed more conventional cometary traits including visible outgassing and typical orbital mechanics. NASA researchers, including Dr. Karen Meach from the University of Hawaii's Institute for Astronomy, have emphasized just how important it is to compare these objects systematically to really understand the true diversity of interstellar visitors entering our solar system. Their cumulative comparative studies suggest a broad spectrum of both natural and potentially artificial objects traversing our galactic neighborhood, hinting at a far more complex and dynamic composition of the interstellar environment than scientists previously conceived. The sequential arrival of 3 on Atlas has really intensified international calls for establishing dedicated interstellar monitoring programs, capable of detecting and tracking future visitors with enough advance warning for detailed study. The cosmic journey. Traveling at incredible velocity with a definitively hyperbolic escape trajectory, 3I Atlas's epic journey from the depths of interstellar space really captures the imagination of scientists and space enthusiasts worldwide. The massive object appears to have originated millions, possibly even billions of years ago in a distant stellar system, and then embarked on this extraordinary voyage spanning both familiar and unfamiliar regions of our galaxy. NASA's Jet Propulsion Laboratory continues to support sophisticated computer simulations designed to understand how such enormous objects could, successfully traverse vast interstellar distances while maintaining structural integrity against all kinds of cosmic hazards. Dr. Alessandro Morbidelli's groundbreaking work in astrophysical dynamics specifically highlights the numerous challenges faced by such ancient cosmic voyagers during their extended journeys through space. The object's observed interactions with solar radiation, gravitational fields, and interplanetary magnetic environments provide invaluable scientific data about interstellar medium properties, directly benefiting ongoing research into cosmic evolution and galactic structure. Its successful arrival suggests either extraordinary durability of natural materials or perhaps possible artificial construction designed to withstand the harsh realities of long-duration interstellar travel. A scientific goldmine. The unprecedented arrival of 3I Atlas presents an extraordinary scientific goldmine, offering unique insights into the chemistry, physics, and material properties of objects originating beyond our solar system. NASA's James Webb Space Telescope has played an absolutely pivotal role in detecting previously unknown spectral lines within the object's complex electromagnetic emissions signature. Dr. Stefano Bagnullo leads international collaborative investigations that have successfully revealed unexpected complex organic molecules and exotic metallic compounds never before observed in natural celestial bodies. The accumulated observational data promises to shed revolutionary light on conditions prevalent in the early universe and the fundamental processes governing planetary system evolution throughout cosmic history. Intensive collaboration among international observatories has dramatically intensified, strategically leveraging multi-wavelength observations across the electromagnetic spectrum to capture the most complete scientific picture possible of 3I Atlas's true nature and composition. Scientists worldwide anticipate that these ongoing investigations will yield groundbreaking revelations capable of fundamentally reshaping humanity's understanding of the cosmos, interstellar chemistry, and the potential for artificial objects traveling between stellar systems. The scientific community recognizes this as a once-in-a-generation opportunity for paradigm-shifting discoveries. Unanswered questions. Despite extensive international study utilizing the world's most advanced astronomical instruments, there are still, numerous fundamental questions about 3I/Atlas that continue lingering without satisfactory explanations. Its documented orbital anomalies, mysterious surface composition, and those completely unexplained outgassing patterns consistently defy comprehensive scientific explanation using established astrophysical models. The persistent inability to detect conventional volatile substances typically associated with cometary objects fundamentally challenges existing theoretical frameworks and classification systems. Significant discrepancies between observed brightness variations and thermal emission patterns suggest complex surface interactions or perhaps concealed internal energy sources operating according to unknown principles. Leading astrophysicists like Dr. Sarah Seeger propose increasingly exotic alternative hypotheses, including the controversial possibility of artificial origin and extraterrestrial construction. The object's complete behavioral profile remains frustratingly elusive to researchers, continuously fueling heated ongoing debates within the scientific community, while at the same time, demanding expanded observational campaigns to decode its persistent enigmas. Each new measurement seems to raise additional questions rather than providing definitive answers, suggesting that 3I/Atlas may represent phenomena extending far beyond current scientific understanding. The mounting mysteries challenge fundamental assumptions about what constitutes natural cosmic objects. The alien question. The profound alien question has resurfaced with renewed scientific vigor as 3I/Atlas continues exhibiting multiple characteristics that many researchers believe point definitively toward artificial origin rather than natural formation. Professor Avi Loeb, the prominent Harvard University astrophysicist and former chair of the astronomy department, argues compellingly that the object's unprecedented properties remain fundamentally inconsistent with any known natural explanations proposed by conventional astrophysics. He suggests that 3I/Atlas could represent a genuine extraterrestrial probe deliberately sent to monitor or actively interact with our developing solar system civilization. This provocative and controversial assertion has sparked intense discussion within both rigorous scientific circles and broader public spheres, challenging established academic orthodoxies. Critics appropriately caution for maintaining rigorous evidence-based standards over speculative interpretations, but the continuously mounting observational anomalies increasingly pressure researchers to seriously consider dramatically expanded paradigms that accommodate the possibility of cosmic intelligence. The escalating debate highlights humanity's gradually shifting worldview as we potentially stand on the threshold of first contact with evidence of non-human intelligence. The implications of either confirming or definitively refuting the artificial hypothesis would fundamentally transform human civilization. Observing the visitor. Intensive observations from major global telescopes have dramatically intensified as 3I/Atlas approaches its closest point to the Sun, offering unprecedented opportunities for detailed high-resolution imaging and comprehensive spectroscopic analysis. World-class astronomical facilities including the Very Large Telescope in Chile, NASA's Hubble and James Webb Space Telescopes, and extensive international survey networks have coordinated completely unprecedented observation campaigns. Dedicated research teams monitor measurable changes in brightness, trajectory, and emission patterns on a continuous daily basis, seeking any anomalous behaviors or structural modifications. The comprehensive data collection efforts specifically aim to capture transient phenomena including possible energy flares, potential communication signals, or unexpected structural alterations that might reveal the object's true nature. The global scientific community universally anticipates that these intensive coordinated observations could potentially provide definitive answers regarding the object's fundamental nature and ultimate origins, possibly marking a genuinely historic moment in humanity's ongoing search for extraterrestrial life and intelligence. The observational window represents our species' only opportunity to study this extraordinary visitor before it disappears forever into the cosmic void. Dawn of a new era. As humanity stands precariously on the brink of potentially transformative cosmic discoveries, the enigmatic presence of 3I/Atlas fundamentally challenges long-held assumptions about our species' place within the vast universe. The object's increasingly complex behavioral patterns hint at the possible existence of a greater cosmic network and unknown intelligences actively operating throughout our galaxy. Leading scientists now seriously consider the revolutionary possibility that Earth and its inhabitants might have been systematically observed for millennia by advanced civilizations possessing technologies far exceeding human capabilities. This profound paradigm shift compels our species to completely re-evaluate our cosmic role, not as passive observers gazing outward at an empty universe, but as active participants within a dynamic, interconnected, and potentially populated cosmos. The ongoing revelations emerging from detailed study of 3I Atlas herald what may represent a completely new chapter in both cosmic understanding and human evolutionary development. Whether the object proves to be natural or artificial, its mere presence has already begun transforming how humanity perceives its cosmic significance and future destiny among the stars. The dawn of interstellar awareness has arguably already begun. The unprecedented insights from 3I Atlas have ignited both excitement and genuine concern within the global scientific community. Whether this massive object represents natural phenomena or artificial technology, its passage through our solar system forces a profound reevaluation of cosmic possibilities. As intensive investigations continue, humanity waits on the cusp of possible contact and discovery. The universe may be far stranger and more populated than we ever imagined. Which aspect of this mystery fascinates you most? Share your thoughts below. If this cosmic investigation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible revelations. What if the Big Bang wasn't the beginning, but a rebirth? What if our entire 93 billion light-year observable universe is just a single object inside a much larger, older cosmos? This isn't science fiction, it's actually a possibility being explored by theoretical physicists who are challenging our most fundamental understanding of existence. The clues might be hidden in plain sight, in the behavior of black holes and the baffling arrangement of the most distant galaxies spotted by the JWST. Let's explore this mind-bending possibility together. The standard Big Bang model. So, how did we arrive at our current picture of the universe? The story most of us know is the standard model of cosmology, first mathematically conceptualized by the Belgian priest and physicist Georges Lemaitre in 1927. It states that our universe exploded into being 13.8 billion years ago from a point of extreme density. From this intensely hot state, space itself began to expand. Over billions of years, gravity sculpted this expanding cosmos, pulling matter together to form the vast, web-like structure of galaxies we observe today. This model is incredibly successful. It explains the faint afterglow of the Big Bang, the cosmic microwave background, and it accounts for the accelerating expansion of the universe. This acceleration, confirmed in 1998, is often attributed to dark energy, which makes up about 68% of the universe. When combined with dark matter, at around 27%, it appears 95% of our cosmos is made of stuff we can't see or understand. This means that all the stars, planets, and galaxies we can observe make up a mere 5% of reality. The bottom line is the standard model, for all its successes, leaves us with the biggest questions in science completely unanswered. The black hole universe theory. What if there's a more elegant explanation, one that doesn't require inventing new particles or mysterious forces? A radical alternative championed by physicist Nikodem Poplawski proposes that our universe was born inside a black hole within a much larger parent universe. This idea flips our perspective on cosmic origins entirely. Instead of a singularity appearing from nothing, the theory suggests a physical process, the gravitational collapse of matter in a parent universe. Think of it like a star many times the mass of our sun collapsing to form a black hole, but on a cosmic scale. In this model, what we perceive as the Big Bang was actually the moment our universe formed inside that parent black hole. This framework elegantly resolves the issue of what came before the Big Bang, as the parent universe provides a clear preceding state. It suggests a cycle of birth and rebirth, where universes beget new universes, stretching back into an unknown past and forward into an infinite future. Quantum mechanics and degeneracy pressure. Here's where things get really interesting, and it hinges on a core principle of quantum mechanics. Have you ever wondered what stops a dead star from collapsing forever? The answer lies in a rule established by the brilliant Austrian physicist Wolfgang Pauli. His exclusion principle states that identical particles, like electrons, cannot occupy the exact same quantum state at the same time. When gravity tries to crush matter into an incredibly small space, this principle creates a powerful outward push known as degeneracy pressure. The more you squeeze, the harder the particles push back. This is the force that supports white dwarfs against collapse, where matter is packed to a density of over 1 million kilograms per cubic centimeter. In even more extreme objects like neutron stars, the pressure is even greater, holding up against densities of over 100 trillion kilograms per cubic centimeter. This pressure is fundamentally different from thermal pressure, which supports a star like our Sun, as it doesn't depend on temperature at all. Proponents of the black hole universe theory argue that this same quantum pressure could operate on the scale of an entire collapsing universe, offering a mechanism to avoid the infinite singularity. The bounce mechanism. So, if a universe collapses, what happens when this quantum pressure kicks in? Instead of crushing down to an infinite point, a singularity where physics breaks down, the collapse could halt and rebound. This is the Big Bounce, a concept heavily explored in loop quantum cosmology by physicists like Martin Bojewald. In this scenario, as the matter of a parent universe collapses, it approaches the theoretical maximum density allowed by physics, known as the Planck density, which is about 5.1 times 10 to the 96 kilograms per cubic meter. At this point, quantum gravity effects become so powerful, they overwhelm everything else. This force stops the collapse in its tracks and triggers a massive, explosive rebound. This rebound event would be incredibly brief but unfathomably violent, essentially resetting the cosmic clock for the new universe. To any observer inside this newly expanding region, that rebound would look and feel exactly like a Big Bang, while potentially preserving information from the prior cosmic cycle. This model is powerful because it replaces the mathematical fantasy of a singularity with a continuous physical process. Evidence from early galaxies. This might all sound like fascinating speculation, but where's the evidence? It might be hiding in the deepest images of our universe captured by the James Webb Space Telescope. According to the standard model, galaxies should build up gradually. Yet JWST is finding galaxies that are bafflingly massive and mature. For instance, the GLASS JWST early release science program involving astronomers like Rohan Naidu has identified galaxies like GLASS Z12 at a redshift of 12, meaning we see them as they were just 350 million years after the Big Bang. These galaxies are already 1 billion times the mass of our Sun, far larger than our models predicted was possible so early on. Furthermore, these ancient galaxies appear to host supermassive black holes that are millions of times the Sun's mass, a phenomenon that standard models struggle to explain so soon after the Big Bang. The Big Bounce model, however, offers a potential explanation, suggesting these black holes could be relics that survived from the previous cosmic era, acting as gravitational seeds. Galaxy rotation mystery. Now for another cosmic puzzle that might point to the same conclusion. In a random and uniform universe, you would expect galaxies to be spinning in all different directions, with a roughly 50-50 split between clockwise and counterclockwise rotations. But that's not what we see. A 2020 study analyzing over 200,000 spiral galaxies led by computational astronomer Lior Shamir found a significant imbalance. There appears to be a preferred direction of spin, an alignment across vast stretches of the cosmos. The statistical probability of this asymmetry happening by chance is less than 1 in a billion. This unexpected alignment, observed across a scale of billions of light-years, implies that processes during the formation of the universe were not as random as we thought. This large-scale pattern challenges the long-held assumption that the universe is the same in all directions, a principle that underpins virtually all of our cosmological calculations. One of the explanations for this strange alignment is that our universe could have inherited the rotation of the object it was born from, like a massive spinning black hole in a parent universe. Schwarzschild cosmology. So this idea of a universe inside a black hole isn't entirely new. It actually falls under a concept known as Schwarzschild cosmology. The name comes from Carl Schwarzschild, who, back in 1916, found the first exact solution to Einstein's field equations describing the space-time around a spherical mass, what we now call a black hole. The model suggests that, well, the observable universe is the interior of a black hole existing within a larger parent universe. From our perspective, the Big Bang was the formation of this black hole, and from the outside, our entire cosmos would just look like a regular black hole. The size of this black hole's event horizon is defined by the Schwarzschild radius, and for a universe with the mass of ours, this radius is, interestingly, remarkably close to the radius of our observable universe. Mathematically, the singularity at the beginning of our universe is similar to the singularity at the center of a Schwarzschild black hole, The edge of our observable universe, which is a sphere with a diameter of 93 billion light-years, acts much like a black hole's event horizon, a boundary from which light cannot escape to an outside observer. Black holes as universe creators. Let's take this idea to its logical conclusion. If our universe was born inside a black hole, what does that imply about the estimated 100 million stellar mass black holes in our own galaxy? It suggests that each and every one could be a gateway, a seed for a new baby universe. This paints, honestly, a picture of a vast cosmic ecosystem, a multiverse where universes are constantly being born. This concept, known as cosmic natural selection and explored by physicist Lee Smolin, could even offer an explanation for the fine-tuning problem, the mystery of why the fundamental constants of physics are so perfectly set for life. If universes are constantly being created, then perhaps only those whose physical laws allow for the creation of stable black holes can themselves reproduce, leading to a multiverse dominated by life-friendly universes. This theory proposes that our universe is so adept at creating black holes precisely because it was born from one, continuing an unending cosmic lineage. Torsion and space-time twisting. For a universe to bounce instead of collapsing into a singularity, you need a powerful repulsive force at extreme densities. One candidate for this force comes from an extension of general relativity known as Einstein-Cartan theory. The mathematics behind this were developed in the 1920s by the brilliant French mathematician Élie Cartan. This theory incorporates a property of spacetime called torsion, which accounts for the intrinsic spin of fundamental particles. This spin is a fundamental quantum property like mass or charge that gives particles an inherent angular momentum. In standard general relativity, spacetime can bend, but it cannot twist, making the inclusion of torsion a significant modification needed for this theory to work. According to physicists like Nikodem Poplawski, at the densities found inside a black hole, the interaction between torsion and the spin of particles would create a powerful repulsive force. This torsion-induced bounce would be the mechanism that creates a new universe inside every black hole, making them not just cosmic destroyers but creators. Cosmic anisotropy. The evidence for a preferred direction in galaxy spins points to a concept called cosmic anisotropy, the idea that the universe is not the same in all directions. This directly challenges the cosmological principle, a foundational assumption in modern cosmology. This isn't just about galaxy spins. Anomalies in the cosmic microwave background radiation, first noted in data from the WMAP satellite and later confirmed by the Planck satellite, also suggest a large-scale alignment. Physicist João Maguejo famously dubbed this the axis of evil because it aligned with our solar system's plane, a result so strange it had to be a mistake, except it kept showing up with a statistical probability of being random at less than 0.1%. These anomalies, once dismissed as statistical flukes or errors in measurement, are now forcing a reevaluation of fundamental assumptions, which is exactly how science progresses. If our universe was born inside a spinning black hole, it would have inherited that axis of rotation, creating a preferred direction that could influence the formation and spin of galaxies. From the impossible galaxies seen by JWST to the mysterious alignment of galactic spins, we are faced with observations that don't quite fit our standard story of the cosmos. The idea that our universe is inside a black hole, born from a cosmic bounce, offers a potential framework to explain these anomalies without inventing new physics. It suggests we might be part of an endless cycle of creation. What do you think? Are we living inside a black hole? Let me know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Future Facts. On August 6, 2025, the James Webb Space Telescope slammed into emergency mode to capture an object that, honestly, just shouldn't exist. Astronomers, including the Pan-STARRS team in Hawaii, expected a dying ball of ice. Instead, Webb's new data on the interstellar comet 3I Atlas just confirmed a chemical nightmare. This visitor isn't just unusual, it's breaking every rule in the book, and the deeper the data goes, the more unthinkable the questions get. So, let's explore this together. Emergency override, Webb's unprecedented response. What does it take to derail the most powerful space telescope ever built? Well, on August 6, 2025, we found out. the James Webb Space Telescope slammed into emergency mode, pausing its entire science program for the first time in years. This wasn't a scheduled observation. It was a high-stakes director's discretionary time override, a procedure so rare it's only the fourth such event since launch in 2021. The target, an interstellar object designated 3I Atlas. Ground-based telescopes had just flagged it for accelerating in ways no one could explain, its spectrum flashing with unexpected metals. The call was authorized directly by the Space Telescope Science Institute director Dr. Kenneth Sembach. The chain of command was short and swift, bypassing the usual committees that schedule Webb's time months in advance. The risk was immense. Webb's schedule is a precise ballet of fuel and orbits. A single unplanned maneuver to observe a target for 5.3 hours could cost a week of other science. But the window to catch 3I Atlas was closing fast. Its trajectory was shifting by the hour. The command was uploaded, and the telescope pivoted, its near-infrared spectrograph, NIR spec, locking onto a target that was rewriting astrophysics in real time. This wasn't a routine target of opportunity, it was a scramble to observe an object challenging our fundamental understanding of visitors from other star systems. Early activity beyond Jupiter's orbit. Here's the first red flag that 3I Atlas was no ordinary comet. It woke up in the deep freeze. Most comets are quiet until they cross inside the solar system's frost line near Jupiter's orbit, roughly 5 astronomical units from the Sun. But 3I Atlas was already active at 6.8 AU, far out where the Sun is just too weak to sublimate water ice. Ground-based telescopes, following up on alerts from observers like Karen Meech at the University of Hawaii, noted a persistent brightening of 0.3 magnitudes in just 48 hours. For an object this distant, that represents a massive increase in its gas and dust output. This sustained activity, producing a tenuous coma when the surface temperature was below 150 degrees Celsius, pointed to a body born in a place fundamentally different from our own solar system. Its engine had to be a hypervolatile ice, something that turns to gas in the slightest warmth of the distant sun. The comet's tail grew at a pace that stunned the teams watching, driven by gases that simply shouldn't have been active so far out. It was the first clue that the chemistry of this visitor, as cometary expert Michael Mumma might put it, was deeply, profoundly wrong. The carbon dioxide anomaly. The moment Webb's NARSPEC instrument locked on, the chemical picture came into focus, and it was a shock. The spectrum was overwhelmed by carbon dioxide. In the cold depths of space, CO2 ice turns to gas at much lower temperatures than water ice, explaining the early activity. But the sheer quantity was staggering, with a production rate exceeding 10 to the 28th molecules per second. Webb's data revealed a carbon dioxide to water ratio of 8 to 1. Let me put that in perspective. A typical comet from our solar system like Hale-Bopp has a CO2 to water ratio of about 20%, or 0.2 to 1. The interstellar Comet 2 I Borisov had a ratio of about 0.4 to 1. 3I Atlas was 20 times more CO2 rich than Borisov. As Dr. Neil Della Russo of Johns Hopkins APL, an expert in cometary composition, would note, this is completely unprecedented. The data was undeniable, with the telltale signature of CO2 at a wavelength of 4.26 microns burning bright and broad. Water was there, but only as a faint afterthought. This wasn't just a comet with extra CO2, it was a body fundamentally built differently, pointing to a birthplace where water might be a trace element, a type of protoplanetary disk our models barely account for. Nickel without iron, an impossible chemistry. This is where the story goes from strange to, well, deeply unsettling. As the team at the European Southern Observatory analyzed the high-resolution spectra, they found clear emission lines for atomic nickel at 3,415, 3,524, and 3,525 angstroms. But the real shock was what was missing: iron. In every celestial body ever studied, nickel and iron are chemically inseparable, forged together in the hearts of dying stars and scattered in a cosmic ratio of about 1 part nickel to 15 parts iron. Yet even with the Very Large Telescope's UVES instrument running at a resolving power of 80,000, iron was a ghost. The data was brutal. The upper limit on iron atoms meant nickel outnumbered it by more than 40 to 1. Spectroscopists like Neil Della Russo at Johns Hopkins would confirm this is unprecedented. The only plausible, though exotic, path is the molecule nickel carbonyl, which is so volatile it vaporizes at just 43 degrees Celsius. This molecule is extremely fragile and would break down under solar radiation, releasing the free nickel. But for that to be the explanation, the object had to form in a place that chemically isolates nickel on an industrial scale, a process unknown in nature. Trajectory anomalies and acceleration spikes. As the chemical data was being analyzed, the teams tracking the comet's path were facing their own bewildering problems. 3I Atlas was not following the clean, predictable arc of gravity. It was accelerating, showing a non-gravitational change in velocity of nearly 0.12 meters per second squared over just 72 hours. While comets do this, the force is usually gentle. The acceleration of 3I Atlas, however, wasn't smooth. The trajectory tracked by the Minor Planet Center showed tiny, sharp jumps. This recalled the mystery of Oumuamua, whose own non-gravitational acceleration was famously detailed in a 2018 paper by Marco Micheli. But this was different. For an object estimated to be 11 kilometers across, this is like watching a mountain suddenly shift course. The Pan-STARRS survey team ran every diagnostic, checking for software bugs or errors in their astrometry. The data was solid. The acceleration was real. It meant the forces acting on 3I Atlas were not just coming from the sun. Something else was at play, something internal or something about its structure that allowed it to move in a way that defied our models, deepening the mystery and fueling speculation that this was no ordinary cosmic iceberg. The lighthouse effect, mechanical light curves. Every object in space tumbles, but 3I Atlas's light curve is anything but natural. Photometric data from NASA's TESS satellite revealed a periodic brightening that pulsed with the precision of a clock, sweeping like a lighthouse beam every 7.2 hours. A tumbling potato-shaped rock would produce a smooth, rolling sine wave of light. This was a square wave, ramping up in brightness by a full 1.8 magnitudes in just under an hour, holding steady, and then dropping off sharply. This implies an object with distinct flat sides and sharp edges, unlike the irregular shapes of natural bodies. Furthermore, outgassing should create torque, causing the object's spin period to change over time. Instead, the 7.2-hour period remained locked in to within a thousandth of a second, a major physical contradiction. An expert on exoplanet light curves like MIT's Sarah Seeger would immediately recognize this as unnatural. The sharp increase in brightness also hints at a highly reflective, possibly metallic surface being periodically revealed to our line of sight. Ancient sky metal, historical context. So, the idea of metal falling from the sky isn't new, it's actually woven into our history. Around 3200 BCE, ancient Egyptians hammered beads from iron they couldn't possibly have smelted. Analysis of artifacts from the Gurtsi tombs reveals the secret. The beads contain nearly 30% nickel. No terrestrial ore has that composition. The only source was a rare type of meteorite called an ataxite. There's a similar story with Tutankhamun's tomb. Buried with him was a dagger with a blade of meteoritic iron containing 11% nickel and 0.6% cobalt, a composition detailed in a 2016 study in Meteoritics and Planetary Science. This iron from heaven was, incredibly rare. The Babylonians also watched the skies, and their cuneiform tablets speak of burning stones as omens. The Akkadian word for iron, and bar comma, is sometimes translated as sky metal. These cultures didn't understand the chemistry, but they knew this metal was different, special, and came from beyond their world. They understood that when the sky delivers something new, it can be both a wonder and a warning. Today, astronomers use powerful telescopes, but the core question remains, when an object arrives with a signature that defies explanation, what message is it bringing? Avi Loeb's challenge to consensus. You can't have a conversation about interstellar anomalies without Harvard astrophysicist Avi Loeb. When the data on 3I Atlas came out, he immediately argued in a new preprint that these are all potential hallmarks of something engineered. In the lab, separating nickel from iron is done via the Mond process, which, kinda eerily, uses carbon monoxide to create volatile nickel carbonyl, the exact chemistry hinted at in the comet's coma. Loeb argues that while the community scrambles to invent exotic natural comets, we must apply Occam's razor. Is it simpler to invent new astrophysics, or to consider an existing category of object we've theorized about, technology? His critics rightly say extraordinary claims require extraordinary evidence. But Loeb's position, now supported by his Galileo Project initiative, is that the evidence is already extraordinary. The project's mission is to actively search for technological signatures, and 3I Atlas fits the profile of exactly what they are looking for. Clinging to familiar explanations when the data screams otherwise is a failure of scientific imagination. Scientific community divided. The case of 3I Atlas split the astronomical community. On one side were scientists working to find a natural, if exotic, explanation. Dr. Alan Stern, principal investigator of the New Horizons mission, had previously proposed that Oumuamua could be a nitrogen iceberg from a Pluto-like exoplanet. Maybe 3I Atlas was a carbon dioxide iceberg from a similar world. Others, like comet expert Dr. Matthew Knight, argued that the non-gravitational acceleration could still be explained by powerful, localized jets. On the other side were those emboldened by Loeb, who argued that we had to take the artificial origin hypothesis seriously. They pointed out that a light sail, a thin reflective sheet, could neatly explain both the sharp light curve and the acceleration. No one was claiming definitive proof, but the idea that 3I Atlas might be a probe, or a fragment of one, was no longer a fringe theory. It was being actively discussed. Peer-reviewed journals and online forums buzzed with debate, as every new piece of data was scrutinized. The object was a cosmic Rorschach test, and what you saw depended on how willing you were to challenge fundamental assumptions about our place in the universe. NASA's High Anomaly Classification. Officially, NASA's Planetary Defense Coordination Office under Lindley Johnson has flagged 3I Atlas as a high-priority scientific object. While it poses no impact threat, its trajectory is being monitored by JPL's Sentry 2 system with an unusual condition code 9, indicating a trajectory so unpredictable it defies reliable long-term projection. This flag essentially tells the entire astronomical community that all bets are off for where this object will be in the future, making follow-up observations extremely difficult and urgent. Internally, this triggers discussions at the highest levels of NASA's Planetary Science Division about the fundamental nature of the object. It becomes a question not just of tracking, but of understanding. The tension between the cautious public statements and the urgent internal scramble to understand what they are dealing with is palpable. The official line is more data needed, but the unofficial reality is that this object is an enigma of the highest order. So what is 3I Atlas? Is it a cosmic fluke, a messenger from a type of star system whose chemistry is alien to us, or is it something more? The evidence is tantalizing and honestly deeply unsettling. An object that moves on its own, shines with a mechanical rhythm, and is made of materials that shouldn't exist in nature. It could be the first definitive proof that we are not alone in the universe, a piece of technology from a civilization far beyond our own. For now, the answer hangs in the balance, locked in the data, awaiting the next observation that could finally tip the scales. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. What do you think 3I Atlas is? Let us know in the comments below. Thank you for watching Future Facts.